question has some similarities to the last one in that they want us to write a function for the volume, but that's really easy in this question because they gave us the lengths are x times x plus 2 times x plus 10. So again, you could draw a picture of this if you like to see a visual of what this box looks like. Now it says find all the possible values of x given that the volume is 96. So we know the volume is 96. You could plug that in. And this is where the controversy in this question began. Because this question was non-calculator, as a student, you're pretty much aware that the answer is not going to be 5.827 or something like that. It's got to be somewhat of a nice number for you to do the mental math. So many students looked at this question and said, well, I've got to solve for x. It's got to be a pretty nice number. And it took them relatively little time of guessing and checking to find out that 2 works out perfectly. 2 times 4 times 12, 96, done. Unfortunately, when the exam got marked, the exam marking guide said any student that just wrote 2 would only get 2 out of 5 marks because they didn't show any of their work. Teachers would argue, well, it was non-calculator, guessing and checking seemed to work very well. Shouldn't that be fine? But they argued that, well, how did they know that that was the only answer, that there wasn't any other answers? So now, typically on exams, and they've encouraged us on tests, if we want you to solve this algebraically, these questions have the following word added. Algebraically, find all the values of x. The province at that time argued that saying all the values of x meant that guessing and checking just finds you 1. You haven't for sure said that there's not others. And they still stood by, those students had to get 2 or 3 out of 5, even though we thought that that was extra harsh. You figured the question out. But if you do have to solve this algebraically, there's some work to be done. First of all, you're like, ooh, it's already factored. But already factored helps you solve something only when one side is equal to 0. So the work you would need to do in this case is first multiply it out. I'm going to multiply these first, x squared plus 12x plus 20. Then multiply the x cubed plus 12x squared plus 20x. And then I can move the 96 over to the other side. How do we factor this? Well, this is the beginning of this unit. We have to use our remainder theorem, our factor theorem, our factor property, synthetic division, all of that. Now, one nice thing is that we already figured out that that x equals 2 worked. Okay, so we can use that as a hint for figuring this out. With synthetic division, this is going to be 1, 12, 20, and negative 96. And if x minus 2 is a factor, we would put a 2 here, bring down the 1, multiply, add, and sure enough, multiply. Works out perfectly to a remainder of 0. So now we can rewrite this with x minus 2 factored out, leaving us with x squared plus 14x plus 48. And this does factor nicely to x plus 6, x plus 8. If this didn't factor nicely, you'd have to use the quadratic formula. And we get 3 answers. So this is where the province argued it said to find all possible answers. However, based on the situation, x is the height of this box. Can you see that you can't have negative lengths? These ones don't make sense. So the only one that does make sense is 2. Should read the question to see what exactly did they want us to find. State the dimensions of the box, and we should write dimensions. 2 centimeters by 4 centimeters by 12 centimeters. You can plug in 2 into your diagram and see what all the side lengths would be to get our final answer. So if I give you one like this, either on your quiz or your test, I will say algebraically, so that you have to show all of the skills that we've learned in this unit. But it's not bad if it's non-calculator. If you do a little bit of guessing and checking, see how that helped us with the equation, we could go right away in synthetic division to something that worked.